Okay, for the second part of 2.1, we went over identifying if it's a function or not. We looked at input-output tables, mapping, and the vertical line test. The second part is I'm going to go over a little bit of vocab and determining what the domain and range of a function is. Vocab we need to know. Okay? We have input, x, domain, and independent variable. These are all the same thing. Okay? They're interchangeable. I could say input, which also means my domain. It's going to be the x variable here. Okay? It's the independent variable. The reason it's the independent variable, I could pick any value to plug into x. I have that freedom. Okay? So that's why it's considered the independent variable. Output, y, range, and dependent variable. These are all the same things. Okay? They're all, again, interchangeable. The output is the range. Okay? It's the y variable, how far it's going up and down. Okay? And it's considered the dependent variable because it's dependent on what I plugged in for x. I have freedom to plug anything into x, but once I decide what I'm plugging in for x, that's going to be dependent, or the y is going to be dependent on what I decided to plug in there. Okay? So that's what these terms are. Now, what we're going to do is be able to identify the domain and range of our function or with the information that we're given. List the domain and range of the data set below. So I'm giving you relations here. 3, 2, 5, 3, 1, 9, 8, negative 3, and 6, 3. The domain and range, remember the domain is our x, range is our y. Okay? What I like to see, or how I like to see you do this, is list our values for the x and y variable. If you are given, again, kind of with blinders, only with what the values that we're given is what I care about. So you usually have a bracket to show that this is going to be our domain, and I'm going to list my x values here. So I'm going to list them. It'd be nice to put them in order. We have 1, 3, 5, 6, and 8. And close the bracket. Okay, for our range, our y variables. Okay, the lowest one I see there, we have negative 3, we have 2, we have 3 now. 3 shows up twice, you don't have to write it twice. I'm going to just write it one time, and then the 9. There's our range. So it's listing the x's and y's that fit into what we have from our function. Okay, this is what we're given, so that's what I wrote down. Now, here we could see every x value, every y value that we were given. If you're given a graph and you're asked to identify the domain and range, now you have to think, okay, x values. Okay, every x point here is going to have an x value. So every point on this line has an x value. Now, how many points could I put on that line? The answer is infinite. There's always room to fit another point. You can always find that space to fit in between 2 points. Okay? So if I ask you to list all the x values, you'd be listing for a very, 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 very long time. Okay? There's an infinite number there. So we're going to write our domain as a compound inequality. Okay? Again, I have my brackets. I'm going to start with the lowest x value that we have. Now, one thing I like to do, I like to box my graph. Here's the lowest point or the most left point. Then go down to where the bottom is. I'm just going to the bottom where the graph is. Go all the way over until you're out to see, okay, here's this point. Draw this one down. I'm going to go over and then finish my box there. Box should have looked a little nice. Let me fix this a little bit. All right. Now what this shows me is how far the x value is, how far the x value is one way to the other. Also the y value going down and going up. You're going to have to do some estimating. Okay? So here we're looking at the lowest x value. That's going at negative 2. So negative 2 less than or equal to x less than equal to the highest x value is 2. Okay, you see it on the x-axis. Okay, you're looking across that negative 2, across the 2. That's where our values are. And then let me get keep it just consistent with color. Bracket there. Okay? Now the y, the range. Okay? We're going to start this off the same way. Where's my lowest y value now? The y value, negative 1 be down here somewhere, so it's not quite at negative 1. I'm going to estimate negative 0.5. Less than equal to y, less than equal to, the highest value there is 6. And close up the brackets. Okay, it went down to negative 0.5, went all the way up to 6, so that would be my range. Okay? The compound inequality, they're both less than and equal to. We have our variables in the middle, our lowest value, and then our highest value. Let's look at one more example. Okay, so here we have a little squiggly line. The graph we had before, it was just one nice smooth curve that went down and up, a parabola. This one, we have it going up, down, then up again. Okay, still just box it. Okay, I'm gonna take this and just start at my lowest point. I'm gonna go over. I'm gonna go up. I'm gonna go over again. And then down. I know it doesn't hit down here. Okay, that's okay. It's still in there, but that was the lowest point. Okay, so I don't need to go. I don't need to make it go up. It doesn't have to hit on all the sides. We still know the lowest y value is still going to be at that point. The lowest x value is still going to be at that point, even though it doesn't hit anything else. So looking at our domain, for the x value, not quite, let's count these. We have negative 1, negative 2, negative 3. It's not quite at negative 3, so I'm going to put negative 2.9. Again, you're going to have to estimate. Okay, it's going to happen. It's not an exact value. If you have negative 2.8 when I have negative 2.9, that's not the biggest deal in the world. X, so we have negative 2.9 less than x, less than the farthest value. We have 1, 2, 3, so it goes to 3. That's right on that line, so I'm going to say 3 for this one. And there's my brackets. Okay, now looking at the range, the lowest value we have negative 1, negative 2, so again, not exactly down to negative 2. I'm going to say negative 1.8. Less than equal to y, less than equal to going up. We're at 1, 2, that's right on 2, so we're going to have less than equal to 2 there. So we have negative 1.8, less than equal to y, less than equal to 2. Okay, so if you can see the values and you could list every single value, I want you to do that. If you're given a graph where infinite values could fit in there, represent it as a compound inequality. So you're going to have to look at the situation and decide what's going to be the best way to show what the domain and range is. Okay, very good.